Good morning, viewers. I am Saraswathi, working as a assistant professor in the Department of Computer Science and Technology. Today, we are going to see about the topic is Hebbian Learning in neural network. Hebbian Learning a rule, it's also known as a Hebb Learning rule. It was proposed by a Donald O. Hebb. It's one of the first and also easiest learning rule in the neural network. It is used for pattern classification. It is a single layer neural network. That is, it has one input layer and one output layer. The input layer can have many units, say n. The output layer has only one unit. The Hebbian rule works by updating the weights between the neurons in the neural network for each training sample. This is an algorithm for a Hebbian learning rule. The Hebbian learning rule is consists of an input out and output. The input has a n number of input and the output is a only one output. Set all the weights to 0. This is the first step. Weight I is equal to 0. I value is for 1 to n and bias is set the bias value is 0. For each input vector, S input vector and T is a target output pair. Repeat the steps 3 to 5. Set activation for input unit in the input vector activation function. The activation function for the input unit. For example, the activation function is xi. Input is a si. Si is a activation function. Input is a xi. Xi is equal to si for all I is equal to 1 to n. X is a input. S is a activation function for all the input. Fourth point is a set the corresponding output value to the output neuron. Set the corresponding output value. For example, y is equal to t. Y is a output. Output neuron is a target output is a t. The updated weight and bias by applying Hebb rule for all the input I is equal to 1 to n. This rule can be implemented by using a AND gate in Hebbian learning rule. The Hebbian learning rule is one of the main learning rule in the neural network. First, the construct the truth table of AND gate using a bipolar sigmoid function. The AND gate in the truth table of AND gate, both the inputs are true means we have to set the output is 1. In either our input is true means the output will be false. These are the conditions for truth table of a AND gate. There are 4 training example samples. So there will be 4 iteration. After that, the activation function used here is bipolar sigmoidal function. So the range is -1 to 1. The range will be -1 to 1. Set the weight and bias to 0. This is a first initial step. Weight will be a 0, 0, 0 for the 3 values and bias value is 0. Set the input vector. Set the input vector to the activation function for all the input I is equal to 1 to 4. That is xi is equal to si. X1, X2, X3, X4. These are the 4 training samples. The 4 training samples has the 4 iteration X1 to X4. First, the weight value is 0 and bias value is 0. Set the input vector value to the activation function for all the input. X1 is equal to -1, 1, 1 and then targeted output T. X2 is equal to -1, 1, 1 targeted output. X3 is equal to 1, -1, 1 targeted output. X4 is equal to 111 targeted value. Step 3. Output value is set to y is equal to t. Fourth step is modifying the weight by using a Hebbian rule. There are 4 number of iteration for the input value 4. First iteration, calculate the weight value. W of new is equal to W of old plus X of Y. X of Y. First value is weight value initially 0, targeted value t plus x1 is equal to minus 1, 1 targeted value into y. The output will be a 1, 1 minus 1, 1, 1 minus 1 t. For the second iteration, the final weight of the first one will be used and so on. The final weight is a 1, 1 minus 1 targeted value. X2 value is a minus 1, 1, 1 targeted value into minus 1. Therefore, 1, 1 is equal to 2. 1 minus 1 is 0. Minus 1 is a 2t. Third iteration, we can calculate the previous weight value. That is W of nu is equal to, the weight value is 20 minus 2t plus x3 value. x3 value is 1 minus 1, 1 into t. X3 value is minus 1. Therefore, 2 plus 1 is a 3. 2 plus 1 is a 3. 0 plus 1 is a 1. And then minus 2 minus 1 is a 3. But 3, 1, 3 minus 3 targeted value. Fourth iteration, the previous value will be calculated. So 3, 1 minus 3 targeted value. And then x4 value is 111 t into y value is 1. Y value is 1. Therefore, 1 plus 1 is a 2, 1 plus 1 is a 2, minus 1, 1 is a minus 2 targeted value. So, the final weight matrix is 2, 2, minus 2 targeted function. The network has the final weight for x1 is equal to minus 1, x1 is equal to minus 1, x1 is equal to 1, x1 is equal to 1. These are the four different combination. x1, x2 value, x1, x2. x2 is equal to minus 1, x1 and x2 is equal to 1, x1 is equal to 1, x2 is equal to minus 1, x1 is a 1, x2 also a 1. These are the four different combination, minus 1, minus 1, minus 1 plus 1, plus 1 minus 1, 1, 1. These are the four different possible combinations of a x1 and x2. The bias value is initially 0. After that, the final weight will be updated. The bias value will be 1 for all the input x1 to x2. And then y value, final weight, minus 1 into 2 plus minus 1 into 2 plus 1 into minus 2, minus 6. Y is equal to minus 1 into 2 plus 1 into 2. That is x dot y, x dot y, x dot y. The x dot y plus x dot y plus x dot y. Next value is a 1 of 2 and minus 1, 2 plus x1 is a 1, y2 value is a minus 2. Previous value will be calculated. 1 of 2, 1 of 2 and then 1 of minus 2. So 2. The result all compatible with the original table. Decision boundary is 2, x1, x1 value is 2, x2 value is 2 and then bias value is minus 2 equal to y. Replacing y with 0. Y with 0. 2x1 plus 2x2 minus 2b equal to 0. Since the bias value will be set to 1. But 2x1 plus 2x2 minus 2 equal to 0. 2 of x1 plus x2 equal to 2. The final equation is x2 is equal to minus x1 plus 1. These are the various applications of a neural network: social media, facial recognition, marketing, personal assistant, healthcare, personalized marketing, patient analysis, and personal assistant. Neural network. This Hebbian learning is one of the neural network learning algorithm. Neural network extract identify the learning features from the data, lacking pre-programmed understanding. Neural components and include neuron connections, weight and bias and propagate functions and a learning rule. It receives input governed by threshold and activation function. The connection involve weight and bias, regulating information transfer. Learning, adjusting weight and bias occurs in a three-stage: input computation, output generation, and iterative refinement. enhancing the network proficiency in diverse tasks. That's all. Thank you.